Welcome to Statistics. These lectures cover histograms and other graphical display of quantitative data. So what is an histogram? Here we say histogram is a graphical representation of frequency or relative frequency distribution. The horizontal scale corresponds to the classes of quantitative data values, and the vertical scale corresponds to the frequency or relative frequency of each class. So this is a very good example here. In this histogram, we have a student heart rate data. So we can see that here on the horizontal section, we have the beats per minute for each. And then the frequency will tell us how many, in this case, how many students we have. So for example, within the class of 56.5 to 66.5 beat per minute, let's say we have 3 students. The next bar, we have a class of students whose beat per minute is 66.5 to 76.5. In this case, we have 10 students. Then the third, students with the beat per minute 76.5 to 86.5, we have around 32 students. So histogram always represent frequency or relative frequency of a class of items. So the horizontal is the classes. Here we have a classes from 56.5 to 66.5, then 66.5 to 76.5, all the way to 106.5. And the whole goal is again to organize our data using again graphical. Now, next we talk about symmetric and skewed. As we said in our earlier lectures, a distribution always have symmetric or left skew or right skewed or uniform distribution. Uniform distribution means all the data have the same quantity or the same number of items. Now the skewness, if it's left skewness, it means the median value is greater than the mean. And if it's right skew, it means the mean is greater than the median. Now symmetric means the mean is equal to the median. So here, if you split a histogram of a distribution down the center, and the left and the right side of the histograms are approximately mirror images of one another, then the distribution is symmetric, which means the mean of the value and the median are the same. Now, a skewed distribution means we have non-symmetric. So when we place a line in the middle, the left side will not be the mirror image of the right side. So a distribution is said to be skewed to the right, which is positive skewed, if the tail to the right of the peak of the distribution is no longer than the tail to the left of the peak. Now, the distribution is said to be skewed to the left or negative skew if the tail to the left of the peak of the distribution is longer than the tail to the right of the peak. And as we said always, to find the skewness, it's always the mean minus the median divided by standard deviation. So if the skew value is negative, it means the median is greater than the mean. If it's skew positive, that's to the right, it means the mean is greater than the median. The next is the stem and leaf plot. So a stem and leaf plot also is a graphic representing a quantitative data that will separate each data value into 2 parts. We have the stem and also we have the leaf. The stem will be the leading value and the leaf will be the next value. So example here, they say we should construct a stem and leaf plot that compares the annual home run production, Baby Ruth and Barry Bonds hit per season. So this is Barry Bonds, 86, 87, 88, 89 to 91. Those are the data. Then also we have Baby Ruth. Now, in order to construct, we're going to have a stem. So here we are using the season from 0 to 7. So the key is 0, 0, and then 1 is 60 home run for root, 61 home run for bonds based on here. So for example, when we say 0, it means the value is 0, 4, 3, 2, 6, and then 5. Now 1 means bond have 16 and 19, while root have 11. 2 means 25, 45. So when we look at the data, we can come, for example, 1920, we have home run 5-4, which means baby root, which means it will be at the 5, and we have the 4. That time we have 2, 54, 54, and 59. So we should know that in order to compare two sets of data more readily, we needed to use the same stem for each. So we have the stem against the leading value. So if it's 21, 2, if it's single digit, then it's 0, as we can see here. So roots have 6, 2, 3, 4, while bonds have only 5 with the period. So here we take 1914 to 1919, which is 6 years. The same thing applied 1986 to 91, which is also 6 years. And we compare their. So next we have what we call the ordered array. An ordered array will be a list of all data in either increasing or decreasing magnitude. So an ordered array means the data is sorted, either in increasing order or decreasing order. Also, data listed in an increasing order are said to be listed in rank order. Now, if it's listed in decreasing order from the highest to lowest, then we said they are in reverse rank order. So example here, we have a personnel records for clothing department store located in the local mall are examined, and the current ages for all employees are noted. Here there are 25 employees and their ages are listed in the following table. It is a desire that their ages be placed in rank order. So these are the ages of all the employees. So the solution, we start from the lowest 16, the highest is 63. And put them in increasing order. Also here we say it is always a good idea to get a look at the order array of the data earlier in your analysis. Examining the rank data produces a good intuitive sense for the data. Also, looking at the ordered array, it is evident that over half of the employees are younger than 25, and only 3 employees are 60 or older. Also, we can easily see that the youngest employee is 16 years old, and the oldest employee is 63. Those are the first and last values. Now, next we talk about a dot plot. A dot plot also is a graph where each data value is plotted as a point above the horizontal axis. So an example here, we have the following table, contains number of wins by baseball Chicago Cubs for a recent 50-year period. Use this data to construct a dot plot. So a dot plot, we may construct a long, we plot each data value on the axis. First, we have a horizontal long line, then we look at the minimum value and the maximum value. So for example, when we look here, we can see the minimum value is somewhere around 35, 61, and the maximum value somewhere around 103 or so. So we look again here, we just construct from 35 to 115. Now, each value, we plot a point. So where we have a lot of points, 1, 2, 3, 4, 5, this will be a value of 76, 77, 78, 79. No. So that would be like 77 points. So each point will represent a value. So from the dot point, we see that most values occur between 64 and 97. So somewhere around 64 here to 97, most of the values. We also have what we call the geospatial graphs. So normally we frequently hear that data visualization specialists refer to encoding data into a graphic. For example, in a histogram, the data is encoded into different categories. Now, if you are creating a corporate map, the data is encoded spatially by placing the data in a region. The region can be county, state, or country. Now, the magnitude of the data is visually represented by color shade. So the data is encoded in 2 dimensions. So again, that will be the conclusion of our lectures. This lecture again focus on how we can use a histogram and other graphical display of quantitative data. Thank you.